Good day. Today we are going to be speaking about domain and the range of a function f at x. So at the end of this session, you should know what is a domain and what is a range and how to find a domain and how to find a range of every function. All right. So now I'm talking about the domain and the range, and then I'm talking about functions, that they are domain and range of the functions. Let us just quickly remind ourselves what a function is. We remember that we had a point that has the x part of it and then the y part of it. Okay, this is where everything began. It began with what? With a point. So if I can give you an example of point, for example, you've got something like 1 versus 2, and then you've got 2 versus 3, and then you've got 3 versus 4, and so on and so on. And then these points, ladies and gentlemen, they have the x part. Each and every point has the x part that we call the x coordinate, and then it has the y part that is called the y coordinate. So we said the functions begin with a point. And then when you look at the point, it turns out that they actually have a relationship with each other. And then the relationship with each other can be described. So how to describe it? And then you look at how you get y using x. So here is your y. Your y is 2. And then in order to get y using x, you just take this x and you add plus 1. And then in order to get this 3, you take this 2 and you add plus 1. So basically, whenever you want y, you take whatever the value of x is and then you add 1. All right? So you looked at these points, and then it turned out that there is a relationship that exists between these points, and then you actually use that to form what? A function. And then now, after forming a function, you then were able to actually plot the graph. This is y, and then this is what? This is x. And then so let's look for the y-intercept of the function. So we just close x, and then we remain with y plus 1. So this is a y-intercept. Remember, with y-intercept, you make x to be 0. So it's same as if this x is gone. You see, y is equal to 1. So here it is. Can you see that? 1. And then what about x? If you want x intercept, what to do? You let y to be equal to 0. So you close here. And then you take this one to the side, and it becomes minus 1. So minus 1 is somewhere here. And you've got minus 1. And then when you connect this dot together, you get this function, which is y is equal to x plus 1. Okay, now what did we say? We said this function is just a lot of these points that are like this, that are connected together. Okay, so from what you can see that this point belongs to this graph. Okay, because actually we used these points in order to find this graph, and then when you found this graph, we then put it here in a form of when you found this equation, we put it here in a form of what? In a form of a graph. Okay, let's say now I give you another point. Let's call this point 8 and 9. Let me write with a different color, and then let's say you say 8 versus 9. And then my question is, look at myself, does this point belongs to the graph, the graph up there, which is y is equal to x plus 1. I'm asking a question. Does this point belong to this graph? Now, how do I check if a point belongs to the graph? So I must just look at the point itself. There's an x part of the point, there is a y part of the point. Now I must take the graph as it is. So here I've got what? Y is equal to x plus 1. Now what I must do is I must take the x part and put it in the place of x, and then take the y part and put it in the place of what? Of y. So this y part, I put it here. I say I've got 9 equal to this x part, I put it here. I say x plus 1. And then what is x? It's 8. So it's 8 plus 1. So 8 plus 1 is what? Is 9. And then here I already had what? 9. So 9 is equal to 9. So what does that mean? Left hand side is equal to right hand side. Okay. So if I want to check if a point belongs to a graph, what I must do is I must take the point as it is, put x where it belongs, put y where it belongs, and then calculate. If I get left hand side is equal to right hand side, then I know that what? Therefore 8 versus 9 belongs to y is equal to x plus 1. Okay. I can pick another point and ask, I will do the same thing. Let me pick another point. Let's say 3, and then let's say minus 2. Does it belong to what? To y is equal to x plus 1. Okay. And then, so what I will do is I will take this equation as it is, y is equal to x plus 1. I take the value of y and put it where it belongs, and then it's minus 2, which is equal to, and then the value of x, and then I say 3 plus 1. Okay, what is 3 plus 1? That is 4. And then what? And then here I got only one number, so I bring it down, minus 2. So minus 2 is equal to 4. Is that true? No, that is not true. So that means that the left hand side is not equal to what? Equal to right hand side. So what does that mean about this point? It means that 3 versus minus 2 does, let me put a different color, not belong to y is equal to x plus 1. So, Mr. Macaba, what are you saying to us? I'm saying something simple, ladies and gentlemen, personalities, is that if I have an equation, I can find out which point belongs to the equation. I can also find out which point does not belong to the equation. So I'll have a set of points that belongs to this equation. Remember, guys, that this y-intercept goes to positive infinity, and then this one goes to negative infinity, this one goes to positive infinity, this one goes to negative infinity. So it continues. So this graph is a continuous graph. It continues. Okay, so even if I can pick any point here, I can be able to put it somewhere into this graph because it's continuing anyway. Okay, so I can pick any point and then ask, does it belong to the graph? I can be able to just put it here and test it, whether it belongs to the graph or it does not belong to the graph. Now, I want you to hold your seatbelts because we are about to take off. Now, all the points, remember, a point is made of x and y. So, all x values that belongs to the graph, so to the function, this means I say function f at x are what? are a domain of f at x. Domain of f at x. So when I'm talking about the domain, what am I talking about? I am talking about all x values that are part of this graph. Okay. Now, what about the range? Now, let me use a different color. All y values that belongs to f at x are what? Are a range. A range. Actually, let me use something. What can I use? It's the same. We call it a range of f at x. So when I say find the domain of a certain function, I'm saying find the values of x that belongs to this graph. If I say find the range of f at x, what I'm simply saying is find the values of y that belongs to where? That belongs to f at x. Now, a best way to find the domain and the range, ladies and gentlemen, is to use a graph. So that is why it is very, very important for you to be able to draw every graph that you are supposed to know how to draw. Because it's sometimes it's very difficult to use the equation. You can use the equation to check points if they belong here. But when you want to check the values of x on their own and the values of y on their own. Okay. So for example, these are the values of x that this graph can take, or that belongs to this graph. Okay, and then these values that are here, so this is part of a domain, and then this is part of a range. Okay, now the question is, and which is the last part of a concept, is to say, how do we then use a graph to find the domain and a range? Very simple. So basically what we should do is, let's say we want a domain. Let's first say we want a domain of this one, of this graph, y is equal to x plus 1, and then this is the graph of x plus 1. Okay, so guys, when we are finding the domain, there's a lot of ways of doing it, but what I always do is I will always start from 0. Okay, remember we said the domain is the value of what? Is the value of x. So what I'm going to do is I'm going to put a line here. Okay, so when I look for a domain, ladies and gentlemen, personalities, I'm saying, what are the values of x that when you project up, or no, not up, basically, they all depend on where the graph is. So if I can project this point of x to the graph, can it touch the graph? If the answer is yes, then that is part of the domain. So let's look at 0. If I can go up with 0, it will definitely touch with this graph. If I can go towards the graph, it will touch it. If I go towards the graph with, say, 2, it will touch it. With 3 and 4 and so on, can you see? It will touch this graph. Okay, and then let's look at this one. -1. If I go up, if I take -1 towards the graph, it will definitely touch it. If I take -2 towards the graph, it will touch it. -10, if you take them toward the graph, but this time around the graph is below, so you take them down, it will touch the graph. So if I'm looking for a domain of a function, and then I have the graph of the function, I just take a ruler or something and then I put it along x. And then I'm saying, what are the values that when I just project towards a function, they will definitely touch the function. So when you look at this one, it turns out that all values of x can touch this graph. Okay, all values of x can touch this graph. Okay, so because all values of x can touch this graph, so what is the domain of y is equal to x? So the domain of y so the domain is what? Is x is an element of real numbers. So x is an element of real numbers simply means that all values of x, it's a way of mathematics of saying all values of x that I can have they can touch this graph. Okay, now let's look at the range. The range, you just put something along y. Okay, and then simply take all values of y, start from 0. Okay, when you stretch 0 towards the graph, can it touch it? Yes, this 0 can. Okay, positive 1 can, positive 2, and so on. Oh, all right, can you see? So from 0 up to positive infinity, all values, you can be able to project them to a graph. Okay, let's look at minus 1 in the y. When you project them, yes, it can touch a graph. Minus 2, remember this goes down all the way, so all the values of y also can be projected to the graph. So the range is what? So the range of this function is what? Is y is element of real numbers, which is the same way of saying all values of y can be able to touch this graph. Okay, so this was the domain and the range of a linear function. Right, now let's look at the parabola. Let's look at parabola. So let's say we've got a function that is y is equal to x squared. All right, and then obviously this function is like this. Can you see that? Yes. Okay, this is y, and then this is x, and then this is 0. Okay, we are looking for a domain and what? And a range. Remember, this line continues and then this line also continues. Okay, so what is the domain of this function? Let's start with the domain. So what do we do when we want a domain? We just put a line along x, because we remember we are looking for values of x that belongs there. Since we know, guys, that this line continues, that means let's start with 0. 0, yes, when you project 0 to the graph, it can touch it. 1, yes. 2, yes. 1.1, yes. 3.5, yes. 100, yes. Can you see? Minus 1, yes. Minus 2, yes. This doesn't go this side, it goes this side. Okay, so all the values of x can be able to touch the graph. So what is the domain of x? Of this graph? It x is an element of real numbers. Okay, now let's look at the range. Okay, so we said what do we do when you look at the range? When you look at the range, we look along y. So what do? We put this line along y, and then we always start from 0. Oh, can you see? Okay, 0. Okay, 0. This graph started at 0. So yes, at 0, at y, which is equal to 0, it can touch it. Okay, 1, yes. If I can project this and this one on the side, they can touch a graph. 2, and so on and so on. So all these numbers from 0 up to positive infinity, they can actually touch the graph. But what about minus 1? Can you see? Minus 1 does not touch this graph. Can you see? This graph, remember, can you see? It only touches here at 0. So when you go down, it doesn't touch. So the range, remember, the range is the values of what? Of y that belongs to the formula. So now you can see that the values of y that belong to the formula are not just anyone in the same way as it happened here, but this time around it's only the values of y that are greater than or equal to what? Or equal to 0. Now the range is changing. Does make sense, right? Now let's go on to the next function. Let's go and look at the exponential function. So let's look at the exponential function. Exponential function. Okay. So ladies and gentlemen, I'm just picking in examples of functions here and I'm showing you how to play around with this function and show the domain and the range. Okay, functions will not always be like this, but if you know how to find it for one, because the method is just the same, guys. When you want to find the x-intercept, you just put a pen and then 0. You start with 0 up to positive infinity. You look at whether if you project these points, can you touch the graph? And then from 0 up to the negative. And then you do the same thing with y. Okay, this is how you find the domain and the range. Okay, so now let's say here we've got something like this. Let's say we've got y, which is equal to 2 to the power x. Now we've got 2 to the power x. This is something like this one. Okay, it's a graph like this. Okay, so you've got x here, you've got y, and then here's a graph. So what is happening here? Let's start with the domain. Values of x. This line, remember, it continues, and then this line also continues. So you can see from here all the points that you can project along the x-axis, they do touch this graph. So what is the domain? So the domain is x is an element of real numbers. Okay, now what about y? You do the same thing. Okay, start with 0. Now I want you to notice here, remember, when you've got y is equal to 2 to the power x, this is an asymptote of this graph. So what is an asymptote? An asymptote is a line that the graph approaches but never touch. So it will never touch this y is equal to 0. Can you see that? It will never touch this line. So y is equal to 0 is not part of the domain. But once you say 0,00001, therefore it starts being part of the domain. And then 1 and 2 and 3 and so on, it becomes a part of the domain. But from 0 down there, you can see there's no graph here. So this is not part of the domain. Remember, the domain is what? The domain is x values that belongs to the graph, and then the range is y values. So the y values that belongs to this graph is only y values from 0, but not including the 0 that I referred to. Okay, so the range is only value of y that are greater than 0. But this time around, you are not including it. Here you included it because this graph is here, it starts here at the origin. But here you can see it doesn't start here. Do you understand? So this is the domain of this function, and this is the range of it. Okay, the stories are very simple, and the story continues over and over and over. When you look for a domain, you just look for the value of x that belongs to the function. If you look for the range, you look for the values of y that belongs to the function. Okay, now let us continue. Now let's say we've got a hyperbola. Going to take a simplest case of an hyperbola. Say y is equal to 1 over x. And you guys know that this is y, this is what? This is x, and then this is 0. And then obviously, because this is positive, it's going to be in the first quadrant and the third quadrant. So you'll end up with something like this. Okay, let me just use a different color so that this could be highlighted. Okay, and then here, aha, there we go. Okay, and then again, we are looking for domain, and then we are looking for a range. Same thing, people, same thing. Start with the domain. Okay, start with 0. Okay, x, which is 0, does it touch this graph? No, it doesn't. Remember, this is an asymptote of this graph. It's the line that the graph approaches but never touches. So 0 doesn't work. Okay, 0 doesn't work. Okay, and then but when you start say 0,0001 start working, 1 work, 2, and so on, and 5 and 100 and so on. Remember, this also continues. So every other number works from 0, but 0 itself doesn't work. Now let's look at the negative part. Okay, minus 0,0001, it starts working, but 0, you remember we said it doesn't work. Okay, minus 1 works, minus 2, minus 100 and so on, it works. So everything works except for x that is equal to 0. So how do we explain that domain? You can just say x is an element of real numbers, but x is not equal to 0. Okay, or some other people will even accept, some other teachers will accept, if you say x is not equal to 0, that will be sufficient for them to say that this is a domain. Okay, now what about the range? So this simply means all values work except for what? Except for x, which is equal to 0. This is why they say r is an element of real numbers, but x is not equal to 0. Okay, let's look at y. You can see y is the same thing. All numbers work, but once you reach y is equal to 0, then it doesn't work. So how to explain a range here? So it's y, which is an element of real numbers, but what? But y is also not equal to 0. That is a domain and a range of this simple basic hyperbolic function. Okay, now let's go on. Let's say we've got a root function. Let's say we've got a root function. Root function. What is a root function? A root function is a function that is like this. You see, this is y, this is x, this is 0. This is a function y is equal to root x. What is a domain? What is a range? Okay, domain and then range. Let's start with the domain. It's x values. You can see it's only from x is equal to 1 when you go to positive that belongs to this graph. Can you see? because when you extend 0, it does touch the graph, 1, 2, and so on. But once you say 0, minus 0,01, then it doesn't touch the graph anymore. Okay, so now what is the domain of here? The domain of here is x that is greater or equal to, because we also include this one, equal to 0. Can you see that? Okay, now let's look at the range. The range is y. You can see also it's y that are up from y is equal to 0 upward. From 0 up to negative, we don't find anything. It doesn't touch this graph. So the range here is what? The range is y, which is greater or equal to what? Equal to 0. Okay, and then let us do the last very lovely function that I love so much, which is called the logarithmic function. We can call it a log function. What is a domain? And what is the range of log? Let's say we've got y, which is equal to log x. So when you've got y is equal to log x, now this is a very beautiful function. It's like this. And then you've got your y here, you've got your x here, you've got your 0 here. Okay, the log graph, as I said, is a very weird function. So what it does is it goes like this. Where is my blue pen? Because my paper, okay, there it is. Or my red pen. So this graph simply goes like this, and then it goes like this. Can you see this line here is an asymptote of a logarithmic graph, and then this is 1 here. You've got 1. Okay, you can look at the video. There is a video that speaks about drawing a logarithmic graph. All right, now what is a domain? What is a range? When you want a domain, you put a line along x, and you can see here the x, which is equal to 0, it doesn't touch this graph, but a value of x that is slightly greater than 0, it starts touching this graph. Remember, it is asymptote. So basically the domain is what? The domain is nothing other than x is greater than 0, and you don't even include 0. Okay, but what about the y? The y-axis, you just put along y. Y is equal to 0, it does touch. Okay, y is equal to 1, it does touch. 2, it does touch. 100, it does touch, because remember this graph continues forever. Okay, it doesn't stop. Okay, just as it continues slowly, and then it goes slowly up, but it never stops. So from 0 up to positive infinity, all values of y, they work. What about 0 to negative infinity? From 0 to negative infinity, this value works, this value works, all other values work as well. So what is the range of a log function? The range of a log function is nothing other than y is an element of what? Of real numbers. Okay, and then now you've got the most lovely function that I'm going to close with. I love it so much. It's called a cubic function. Cubic function. Okay, now, okay, maybe I'm not supposed to say this because I'm teaching you guys to cheat. Guys, when it's come to cubic function, I don't care how a cubic function is, as long as it is a cubic function. the domain will always be x is an element of real numbers, and then the range will always be y is an element of real numbers. Literally always. It's a very beautiful function. It's a function that behaves, because if I can give you a cubic function, even if I put it here and say it goes like this, and then at the end of the day this line goes down and then this line also goes down, so it covers all the values of y, and then all values of x are covered. So NB in a cubic functions, the domain is always it's always x is an element of real numbers, and then the range is always an element of real numbers. So ladies and gentlemen, I hope by now, if I can give you any function, you can be able to actually, you must go and learn how to draw graph. There are some videos in this channel that teaches you how to draw graph, so you must go to them and just look and see how you create graph. But it is a given, you can say from here, it is a given, you must know how to plot graphs. If you do not know, you must learn it. But once you have a graph, it is very easy to set the domain and to set the range. You just look at the graph itself and see which values of x that can be projected to this graph and which values of x cannot be. But ladies and gentlemen, thank you very much for tuning in. This is Mqondisi Macaba from Tsembela Maths Club that helps learners to understand mathematics. Thank you very much for tuning in, and have a lovely day, and goodbye.